Today our topic of discussion is Mart sort. So what does sorting actually means? Sorting means that we have been given a group of numbers or alphanumerical characters and we need to arrange them or sort them in some logical fashion. By logical fashion, I actually mean that either you need to arrange them in ascending order or in descending order. So suppose let us consider a group of numbers given to me. Say we have been given 5, 1, 4, 3, 2, 5, 1, 4, 3 and 2, and we are calling this group as num. Okay, its position is 0, its position is 1, its position is 2, its position is 3, its position is 4, because the array position always start from 0. Okay, now the problem with this list is that this is not sorted. This is not a proper arrangement actually. So we can say this is an unsorted list. So we need to sort it. So the problem is to sort or arrange the unsorted list. So we have been given a problem and we need to find the solutions to this problem. So there are several solutions by which we can solve this problem. Some of the solutions are, say we have bubble sort technique, we have insertion sort, we have quick sort, we have selection sort. All these techniques are actually going to solve this problem. You can choose any one of them. But the problem with these techniques is that in worst case time complexity of all these techniques is big O of n square. That means if we are working with large amount of data, suppose we have been given a large amount of large numbers, then it is going to take a huge amount of time. So it is inefficient. Okay. So, but we need to solve this problem in an efficient manner. So how we are going to solve this? With the help of a technique known as Mart sort, which we are going to discuss today. And for Mart sort, the worst case time complexity is big O of n log n, which is less than big O of n square. So therefore, Mart sort is much more efficient as compared to all these sorting techniques. Now, before discussing Mart sort, we need to know some basic logics. That means, suppose before I am going to discuss the algorithm, I am going to tell you how to devise a computational model or a mathematical model. Suppose say we have been given a machine and its name is merge. I am writing M as a shortcut, okay, and we need to give this machine or this computational model or mathematical model an input, and the input is an unsorted list, and what the machine is going to give me as an output is the sorted list. Okay, so actually if you consider that if we give this unsorted list to this machine, and this machine is going to work, and then it will give me an output which look like this. One, 2, 3, 4, 5. This is the same array or the same list, but what is the difference is this, what is the difference between these two lists is that this is sorted, but this is unsorted. Now the question is how the computational model is going to work. That means we need to know the recipe behind this working of the machine. That means the recipe, I actually actually want to express the algorithm. Okay, now once we have devised this algorithm, then this machine will work on the basis of this algorithm, and it will convert the unsorted list into a sorted list. Now we are going to observe how this algorithm or the recipe works. Basically, there are two things we need to consider. Two computational models actually. One of them is merge sort and another one is merge together. You can name it anything. Okay, and what does it do? It's going to divide the given problem into sub problems, and its task is to combine all the solutions of the sub problems. Now let us discuss these two things more in details, or you can say more in depth. Okay, so how does this work? How the machine, how our computational model is going to convert this unsorted list into a sorted list, which is this. Fine. Now suppose we have this unsorted list 1 2 3 4 and 5. This is 5, this is 1, this is 4, this is 3, and this is 2. Its position is 0, its position is 1, its position 2, 3 and 4. Fine. Now this is unsorted, so we need to give this whole list to the computational model merge. So after giving this whole list to merge, what merge is going to do is that it's going to divide the list into two parts. Okay, so first of all, let us see actually what is the length of this list. The length of this list is actually 1 2 3 4 and 5. Okay, so after breaking the list, we will get two sublists. So I will call one of the sublist as left sublist and another one will be the right sublist. Now this is a sublist and this is also a sublist. Now the question is that what will be the length of this left sublist and what will be the length of this right sublist. Okay, so what we are going to do is that we need to divide this length into two parts. So if we divide 5 by 2, we will get 2, not 2.5, because we are dividing two integers values, so we will get 2. Fine. And let this 2 be the length of the left sublist. Say here we are calling this as, say, left length. So this is left length. Okay, this is also an integer array, and the remaining length is obviously the total length of the array minus this left length. That means let us call this thing as right length. So right length is the total length subtract the left length, whatever the remaining length is. Okay, so our right sublist is going to have a size right length, which in this particular case is basically 3. 3 plus 2 is 5. So if left sublist is of size 2, then this obviously is going to have the size of 3. Now after breaking this array, we will get this thing. Let us analyze the problem. 5, 1, 4, 3 and 2. Now we are going to divide this into two parts. After dividing it, we will get two sublists. The first sublist is of size 2. That means here the sublist will contain only 2 elements, and this sublist is of size 3. That means this sublist will going to have only 3 elements. This is my left sublist and this is my right sublist. Okay. This sublist will contain element 5 and 1, and this sublist will contain element 4, 3 and 2. Now what we have actually done is that this problem we have divided or partitioned the given problem into 2 sub problems. Now we will consider these 2 lists. Okay. Now this list is again unsorted, so we need to give this list to we need to again insert this sublist, actually both the sublist to the M or merge computational model. Fine. It will look like this. This is our machine and we are giving the left sublist as an input, and we will get some output which is sorted. Obviously it's going to be sorted, and again we are going to give the right sublist, which is also a sub problem, to the computational machine or the computational model, and again it will generate some output which will be sorted. Now if we observe the partition more into details, let us see what will happen if we give the left sublist to the computational model merge. It is again going to divide these 2 lists into 2 parts. One is 5 and one is 1. Now the question arises that how far we are going to divide the problem. We are actually going to divide the problem unless and until the sub problem will contain only 1 element, because if a list contains only 1 element, there is no need to sort the list. Okay, so the left sublist is going to divide into 2 parts, 5 and 1. Okay, now after this thing, what will happen? I am not discussing about what will happen in the right sublist now. Let us fully concentrate on what will happen if we give the left sublist to the merge computational model. Okay, so the merge will accomplish its task. Now what we're going to have now is that we're going to give these 2 individual sublists to another computational model which is merged together. I am naming it as MT. Okay, so we are going to give, this is our left sublist, this is our right sublist. Of course we are going to give both of them to the merge together, and what the merge together is going to do is that it's going to compare both of them, and it will put back the sorted list into this original list. That means actually what will happen is that after comparing these 2 things, the unsorted list will look like this: 1 and 5. Fine. This is actually the task of the merge together. It will first observe which one is greater. Here we have 5 and here we have 1. So of course 5 is greater, so we don't need to put 5 over here. So 1, since 1 is smaller than 5, we need to put 1 first, because we are arranging the list into ascending order. Fine. Similarly, if we observe what will happen if the right sublist is given to the procedure or the computational model merge. Our right sublist is like this: 4, 3 and 2. 4, 3 and 2. Now after giving this right sublist, this is our right sublist, we have been finished with this sublist. So right sublist. So right sublist, after we give this right sublist to the procedure or the computational model merge, the merge is going to again partition it into two parts. The first part will contain, its size is actually 3. So if I divide 3 by 2, the answer will be 1. The first sublist or the left sublist of this list or this sublist is 1. So here it will only contain 4, and the remaining sublist will be 3 and 2. Now this is already sorted. Even if I give this to, there's no need to actually sort this thing. It's already sorted. We are done with this thing. Now the main problem is with these things, 3 and 2. Okay, they are not sorted. So we need to again give this thing to merge, and after giving this to merge, it will again generate two sublists of individual length or 1 unit of length. Okay, then look here, they are all sublist, 4, 3 and they are all sublist, but they contain only one element, so there is no need to sort them. Okay, so what I need to do is that I need to put this 3 and 2 in some logical fashion. So I will obviously give them to merge together computational model, and it will generate some output which will be sorted. So the output will look like this. Fine. And similarly, we have this sublist also, which is 4, and we'll give these two sublists together to merge together like this. This I am calling this as L and this is R. So after giving L and R to MT, that's merged together, it will also generate some output which will look like this: 2, 3 and 4. So our original problem was like this. 5, 1, 3, 4 and 2. No, sorry, this is 4 and this is 3 and 2. Okay, this is our actual problem, and after doing some computations we arrived at this stage where we have the left side sublist look like this and the right sublist look like this: 2, 3 and 4. This is our right sublist after the computations. Okay, now this array or this list is not yet sorted. We need to sort it. Now what we are going to do is that merge sort has finished its work. Now we are going to give these two sublists to merge together, and what merge together actually does is that it compares the first element of this list and the first element of this list. So let us analyze how we're going to do this work. So the original list contains 5 blocks. This is position 0, this is position 1, this is position 2, this is position 3, this is position 4. Fine. Now what merge together is going to do is that it will first compare this element of the left sublist and this element of the right sublist. Whichever is smaller will be inserted to the 0th position of the actual list or the num list. Okay, so I am observing that 1 is lesser than 2, so I will put 1 over here. Okay, now 1 has been deleted. Now we have been left with 5 in the left sublist and 2, 3, 4 in the right sublist. Now I will compare 5 with 2. Whichever is smaller, put it over here. 2 is smaller, removed. Okay, then I will compare 3 with 5. Whichever is smaller, put it over here. 3 has been deleted. Now I will compare 4 with 5, whichever is smaller, put it over here. And I will compare. There is no need to compare actually, because the right sublist is exhausted. So I simply put this 5 over here. Now look, this is sorted. This is completely sorted. Okay. Now I will discuss how this thing actually works. Let us write the algorithm first. Let us write the algorithm. Algorithm for merge sort. Void merge sort. Okay. You need to give it the input array or the problem or the actual sublist. Okay. Then you need to give the size, which I am calling it n. Then at first you will check that if n is less than equals 1, you don't need to do anything, because if a list contains only one element, there is no need to sort. So it will simply return. It will simply return. Or else what you are going to do is that we are going to work like this. Int left length, which you already discussed, is n by 2, and int right length, it means the length of the right sublist or the size of the right sublist, is n minus left length. Now we need to make two arrays. One is left of size left length, and another array right of size right length. Okay. Now we need to insert elements. For this I require two loop variables or loop counter variables, say I and j. Fine. So for loop, we'll use a for loop. For I 0 to I less than left length I plus plus, and left I is num I. Fine. And similarly we need to put elements in the right sublist also. So j0, j less than right length j plus plus, right j num I plus plus. Then now we have already created two sublists. Now we need to give these two sublists to the procedure merge sort, as we have already discussed. So merge sort left, and we need to mention its size. That means left length. Similarly, we need to give merge sort right length. And now after giving this to giving the right and the left sublist to the merge sort, we need to call the procedure merge together, because these two, because the merge sort is going to complete its task. Now we need to merge together the sublist. The sublist we need to merge together, because unless and until we are merging together, we are not going to get the solution. So what I need to give is that the original array, the left sublist, the right sublist, the size of the actual sublist, original sublist, the left length and the right length. Like this. Okay. The merge procedure is finished. Now we are going to discuss the merge together procedure. Merge together. Look, we are giving this procedure 3 arrays. So we need to mention like this: int num, int left, int like this, right, n, left length, and right length. Now we need to go through 3 arrays, so therefore we will make 3 counter variables I, j, and k, and I will initialize this 0, j as 0, k as 0. Now what we're going to do is that we need to check while I less than left length and j less than right length. We need to perform these 2 things, and now we need to check check this. If left of I is smaller than right of j, actually not I, then whichever is smaller, put it in the num array, which is k. Since left I is smaller in this particular condition, so I'm going to put this, and I simply need to increment this. Similarly, we need to write like this, and suppose this condition does not hold, that means obviously right j is smaller, then we need to put num k equals to right j. And j plus plus, and I need to mention I plus plus also, because if we don't increment, then how I am going to reach the left length, -1, and k plus plus. The while loop is over. Now after this thing, either this condition or this condition will be exhausted. Okay, either of the 2 sublists will be completely exhausted, so I need to check again, because we don't know which sublist is going to exhaust. So while I less than left length num k is left of I plus plus, k plus plus. Similarly, we need to write like this: while j less than right length num k is right of j, then increment j plus plus and k plus plus. Finished. Then simply we need to put the curly bracket. So this is our whole algorithm. Fine. If you have enjoyed this video, please subscribe and like. Thank you.